So what is A/B testing? I like to talk about this starting from an example of decision making, because essentially A/B testing is a tool that helps you to make decisions based on data, or make reliable decisions based on data. Imagine you need to make a very important decision in your life. For example, you're choosing between two majors in the university that you're studying in. You are choosing between A, data scientist major, or B, medicine major. How would you approach this decision-making process? Well, one option would be to ask around different people who studied data science and who studied medicine, and how did they like that, whether that was fun for them or not, what were their opportunities and prospects after those both degrees. But of course, those people are very different from you. So unless you're finding someone who's extremely similar to you, has very similar preferences, goals, interests, very similar level of energy and ability to learn, then answers from different people are actually not going to be very helpful to you, or at least not as helpful as if you would kind of know for yourself how would this turn out. So if we could introduce here a little bit of magical or slightly dystopian approach, the most ideal way to determine which decision would be best for you is to actually see how both decisions would sort of pan out for you. So in this case, you could, let's say, clone yourself and have the clone A, Alice, go to study data science, and clone B, Bob, go to study medicine. Then over time, you would look at how this is going for both of them, who of them is turning out to be happier. Let's see, for example, you see that Alice at some point in time is way happier than Bob. So you decide to go for data scientist major because you don't want to wait anymore, and you go with the option A, Alice. So now you can sort of kill off this multiverse, the multiple timelines of Alice and Bob, and go back in time and actually take the same path as Alice. But what if you would have looked at the happiness level over time for Alice and Bob at a different point in time, and you would notice that Bob is actually much happier than Alice? Should you have made the decision at this point or at the later point in time? How would you know when should you make this decision? How would you know when should you stop the experiment? Or another option would be if, sure, maybe Alice on average is way happier than Bob, but at the same point, Bob is earning way more money than Alice over time. And you know that maybe financial stability is way more important for you than happiness. So in this case, how would you make a decision? How would you go about choosing between financial stability or happiness? And how would you know if you can even trust any of those options? How would you know that if you take the role or the place of Alice and go with data scientist major, your life will turn out the same exact way as her life did? Well, this question actually cannot be really answered with one single clone, but it could be answered if you had, I don't know, 100,000 clones that go with the data science route and 100,000 clones would go with the medicine route. And this is sort of a weird example of how the decisions are made in big companies with either digital products or not necessarily even digital products. So this approach translates really well to large-scale decision-making in digital products. Essentially, instead of having one clone that does one thing and the other that does the other thing, they would have a sample of their user base that is representative of the larger sample of the whole user base that they have. That will go with option A or option B. And in this case, instead of you choosing a university major, this will be a product manager or a product owner of a part of this digital product, deciding whether this new feature is beneficial for the company and the users of the product. So they will select a part of the users that they have, for example, 1% of the users, if that's a sufficiently big enough sample, and show this feature to this group of users. Based on how those users interact with this feature, whether they like it or not, whether they are more engaged or not, depending on what is the success metric for this experiment, they will see how the rest of the population will react to this feature. Then they will ask their data scientists to evaluate whether they can trust those results, whether the results are reliable. So that usually means that if they release this feature to the rest of the user base, that this user base will have approximately exactly the same experience as the testing group. And if the answer is yes, then they can successfully roll out this feature to the rest of the user base. This approach to decision making is A/B testing, often called as well multivariate testing, hypothesis testing, or experimentation. This is the tool that allows companies with digital products, but actually not only digital products, to understand whether the improvement that they're trying to implement in their product is actually an improvement. It is based on many different technical areas, from software development, data engineering, of course, statistics, to product management and design. There are plenty of examples of big companies doing A/B testing on their products, and if you own a smartphone or have an email, pretty much most likely you're a part of 100 or even more A/B tests at the same time. If you ever open Facebook or Instagram, you're most likely to be exposed to one or many different A/B tests, and very likely that your experience will be very different from a person sitting next to you on the subway opening Instagram at the same time. From Google testing 50 different shades of blue for their buttons of call to action, to Facebook changing the arrangement of the feed, this all is done through A/B testing. So the scale where you can apply the knowledge of hypothesis testing is actually super wide. You can do it in pretty much any company, and it does not have to be a digital product.